Good morning, everyone. My name is Jeremy Ward. Get started here. I've been building things for the internet as a hobby since about 2005. In 2008, my hobby became my career. I transitioned from a career in athletic training and strength and conditioning to a front-end developer, in no small part due to a hobby app that I had called MyFitterX at the time. It has served me well. It'll actually serve as the live demo for this presentation, actually a later iteration of it called FitterMe. About the same time in 2008, I started, getting ahead of myself apparently. I started dabbling in Ruby on Rails over time, over maybe about 5 years. Eventually transitioned to the dark side or the server side of the software development world, and I've been doing that ever since. I'm currently a software engineer 3 on the FishMe team at Cofense. FishMe was recently acquired by Cofense, so now the simulator product, which sends out simulated phishing emails on the corporate level, is now known as FishMe. And I'm here today to talk to you about GraphQL. We've recently made the decision to start using GraphQL in some of our front-end projects and microservices, and would like to share a little bit about that. So in this talk, we'll compare our existing API standard, REST, which has served us very, very well, to GraphQL. I'll introduce you to some of the basics of GraphQL, and we'll show you how GraphQL looks and how it feels in a Rails application. And we'll discuss how to start using GraphQL in your applications. And toward the end, we'll talk about what we're doing on the FishMe team and how we plan on using GraphQL moving forward. So REST, our current standard. It's served us very well like a dark night on the wall. Anyone remember the dark days of chaotic, wild APIs and SOAP? Yeah. So for the better part of 2 decades, REST has done us very, very well. In essence, REST can be distilled into 4 virtues. So uniform interface, it's stateless, it has a clear separation between the client and the server, and it's cacheable. So as a uniform interface, what this basically means is that we always use HTTP verbs. Get, put, post, delete, you know them all well. We don't always use them correctly, but they're there. We always use URIs as our resources. And we always get an HTTP response and status, or HTTP response status, and a body back as a response. Stateless. Each request is self-descriptive, and it has enough context for the server to actually perform whatever it's supposed to do. Pretty self-explanatory. Client-server separation. There's clear boundaries, as it says. So basically, there's a contract. One entity has to serve the function, or has to be the entity that's doing the calling. The other, being the client, has to function as the entity making the requests. And it's cacheable. Unless noted otherwise, a client can cache any representation. This is possible thanks to the statelessness of the REST request. Every representation is very self-descriptive. But along with REST, and though it has served us very well, there's some pain points that we see more growing points than pain points. REST is rigid, as we've already talked about. There's 5 resources that we'll generally use, using the different HTTP verbs. So we're going to use GET request for index, POST request for create, another GET request for show, patch update for updating and delete. This is great, but it kind of ties us to a structure, and there's a lot of boilerplate with this. which brings us to why REST is rigid. Lots of boilerplate. While not exceedingly difficult, specifying all the URLs, all the routes, it becomes, then you have all the controllers, it becomes tedious and time-intensive, just monotonous boilerplate work. All the while, we're making the assumptions that the data the client interface actually needs, and they might not even use it. And you know what happens when we start making assumptions? So what we end up with is, if we have to make a change in the design to our API, at best, it's a simple internal code update. If it's a public-facing API, which, how many people in here work on public-facing APIs? A good chunk of us. If we have to make a public-facing change, it's probably going to require a new version bump of our API. That gets expensive pretty fast. In many cases, our server-side code is the most rigid part of our system, and is considerably more difficult to change. This leads to a situation where we tend to implement our clients around the needs of our servers. And if you think about it, who should we put first in any of our projects? The end user, the client. So putting the server first, putting the server's needs above the client, that's really bass-backwards. Ideally, the server should exist to serve the client. It's in the name, right? Server. So it needs to be responsive to the changing requirements of the client. We all have product owners. Anybody get a new request last week? Yeah, it happens all the time. So requests come down, and we need to be able to respond to those requests very quickly. REST is wasteful. Wasteful is probably a little bit of a harsh term, but sometimes it gives us too little, and we have to ask for more. That's underfetching. Sometimes it gives us too much, and we have to ask, well, it's overfetching, and we're left with a pile of data that we really didn't ask for and need, or we really don't need to use. Both are less than desirable, especially from a mobile device that may have limited network connection. So classic case of underfetching. We have two REST requests. This is a simple blog post. We have the posts, and we have the comments. For whatever reason, a request comes down, and we need to display all the posts and all the comments. Don't ask me why. That's just came down from the product owner. And so now we have to make another HTTP request to get a post's comments for however we're displaying that on the page. So we're making essentially n+1 HTTP requests on the client side. Not exactly the best case scenario. A real-life example of this can be highlighted with putting a toddler to bed. Anyone ever have to do that? So I have a 3-year-old son at home. He just turned 3. And the bedtime process is exactly that. It's a process. So I'll put him to bed, and kiss him goodnight, and we start to walk out and close the door. Daddy, Daddy, I'm thirsty. Okay, son. So I go out. He tells me that he wants milk. I come back in with milk. He gets milk. Trying to leave again. Daddy, Daddy, I need my green blankie. Go out, get my green blankie. You see where this is going? Daddy, Daddy, I need my teddy bear. And on it goes. So, lots of requests. So the next night, how do we solve that? I mean, that's the question. So how do we solve this problem for our product owners, and how do I, as a parent, solve it for my son? We overfetch. Simple way to do it, we cram the comment into the post and give them back everything. Here it all is. So the next night I put my son to bed, and I'm thinking that I have him beat. So I bring in the milk, I bring in the blankets, I bring in the teddy bear, I bring in a flask of Tullamore Dew. Clearly there's a authorization problem with my parenting endpoint here, but fear not. If he tries to access the flask of Tullamore Dew, I'm sure that he will get an access denied. So overfetching. So that's a problem. So what are we left to do? This is obviously a problem. Well, a friend of mine offered parenting advice, clearly he doesn't have kids. Gives me a book. Not exactly helpful, but all solutions are on the table. But this is, well, funny, it's slightly less helpful for our blog. So we might do something like this, where we come up with a custom endpoint. Anyone have any custom endpoints in their application that, it's kind of a specialized endpoint for a more generic concept? Yeah, this is how we kind of solve these. We come up with a custom endpoint. This is, so now the clients that need the posts and the comments, they can hit this endpoint. Well, this is interesting for our REST application because now we're kind of breaking our REST contract. And as Nietzsche said, battle not with monsters lest you become a monster yourself. So our defender of the wild and chaotic APIs on the wall has now stared into the abyss, and the abyss has stared back, and now he's becoming what? REST is becoming what it's been protecting us against. So this is basically our APIs start to become harder to maintain, and we find ourselves loath to work on it, which is undesirable all around. REST is laborious to document. I probably can just leave it at that slide. We've all struggled with documentation with REST APIs. It's often manual. It's probably going to require a markdown file, maybe some JSON files in the case of Swagger. It's hard to ensure it's up to date. You make an API change, maybe you update the document, maybe you don't. Anyone come up with ever run across the case where you try to use an endpoint and it doesn't work as expected? It's especially challenging for fast-changing internal APIs. On the FishMe team, we've run into this with a microservice where we had the internal API for the microservice was changing very rapidly, and the UI would be continuously broken because we have to readjust things, and those things don't necessarily translate to the documentation. But to give a good example of a REST API, I would refer you to Stripe's API. Anyone had the pleasure of working with the Stripe API? Probably one of the best documented and up-to-date examples that I can come up with. I'm certain that there's others. So GraphQL, a new hope. GraphQL was developed by Facebook in response to these types of problems or issues with REST APIs. They wanted to improve the performance of their new native apps by fetching the exact data each view needed. Now, this happened, I believe, back in 2012, and they ended up releasing the public version of GraphQL in 2015. So they worked on it for quite a while and put a lot of good thought into it. So the Facebook engineers, they also wanted to design an API where versioning and documentation were much easier. With GraphQL, there is no versioning, which is we'll talk about in the live section. In short, they wanted to empower the client, which is something that we should all try to do, is empowering our clients. And GraphQL does exactly that. So GraphQL defined a query language for your API. Well, that's not exactly helpful. But don't look at me, I didn't come up with it. This is straight from the GraphQL.org website. So what does it mean exactly? Well, they offer a follow-up paragraph to that terse definition. GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. GraphQL provides a complete and understandable description of the data in your API, gives clients the power to ask for exactly what they need and nothing more, makes it easier to evolve APIs over time, and enables powerful developer tools. There's a lot of stuff happening there. It sounds very exciting. I still have no idea what GraphQL is. So with that, maybe we can get a better sense of what GraphQL is by comparing it with our pain points of REST. So where REST was rigid, GraphQL is very flexible. In GraphQL, the client is in charge, as we've already said. The client specifies what data it needs, and the server only responds to what is necessary. So here's an example. Here's an example post to retrieve posts, their ID, and their title in GraphQL. So this query will actually return this response: data, post, ID, title. Pretty simple. So the query type of posts and the shape that you give it is the exact response that you get back, which is very empowering. You know, if you're thinking of developing in an Angular app or Vue or React components, you know exactly what you're getting back. You know exactly what to expect. One thing to notice here is that all GraphQL requests go with one HTTP method, and that's post. And this is because you can create, you know, long, complex queries, and if you try to put that in a GET request, you're going to run out of URL max length very quickly. So in Rails, it's going to be a post request, and will be parsed appropriately on the back end. GraphQL is frugal, so this goes along with what we just talked about. You get back exactly what you put into it. So if you want posts and ID and comments and author and body, you're going to get that back as well. So you get it back in exactly that shape. If you don't want the comments, leave out the comments. If you want the comments but only the author, leave out the comments body. GraphQL is easy to document. Don't worry about the fuzziness of this slide. This is a screenshot of GraphQL. It is the query viewer, UI viewer for GraphQL, and we'll explore this here in just a second, but exceptionally easy to document. And basically, GraphQL provides machine-readable metadata that describes your API. That's a really fancy way of saying GraphQL is self-documenting and is browsable. And it makes discovering APIs nearly trivial. Front-end developers would have access to this, and everyone on the team has access to the same documentation. All right, so now is where the rubber hits the road, I guess. And because of it, I lose my speaker notes. We go old school and use note cards. All right. That's pretty tiny, isn't it? All right. Let's try to bump up my resolution. That a little bit better for people? I think that we can actually might be able to make use of it. Okay. So for GraphQL, let's see if we have access to everything that we need here. So in a Rails project, we start by adding the GraphQL gem. Pretty simple, pretty straightforward. We're going to bundle install and a Rails generate GraphQL install, and that gives us the GraphQL interface and everything that we need. Basically adds this route to our dem file. This is our graphical route. It's the documentation viewer. It auto-generates it behind the development environment, which is for security purposes. You can further lock that down. And then we have our post graphical endpoint. And so this is going to post to the GraphQL controller and the execute action. I can, yes. How's that? And let me get rid of.
Yeah, it's still hard to read. Is there a way to turn the front lights off? Yeah, the lighting is better.
I can also lighten the screen or try to change the color scheme. Live demos, they say. We'll get some here. Okay, so this is the GraphQL, or the graphical UI, served from localhost 3000. I just have the FitterMe application running locally, and with the graphical endpoint. And so you can read here as a little blurb about what it is, but this is our documentation on our query type. So if we click this docs arrow over here, and then get back all the way here, we see that we have a GraphQL schema provides a root type for each kind of operation. So with us, anytime that we're looking at fetching data, it's going to be a query type. Anytime that we're looking at updating or creating, updating, or deleting data, it's going to be a mutation type. I didn't think that I'd have enough time to talk about mutation types, so I just wanted to touch on that, but there won't be any examples of mutations. I can click on query, and these are my initial query types. So when I say query type, let's go back to the code. So we end up with a FitterMe schema. So this is our schema file. This is our entry point into GraphQL. So we have our query and our mutation types. Inside, so this is in a directory called GraphQL, where we have directories for mutations and types. So we're only going to be talking about types right now. So keep in mind that that types just goes into the types directory, and then they're auto-loaded. So as we're talking about query types, so under the query type, this is our entry point into anything that we want to fetch from GraphQL. So if we want to see the circuits, so the circuit in FitterMe is a circuit training workout. We can easily do that. So and we can look at that through through the interface that we have circuits. So over here, I can get rid of all of this mess. Oops. Oh, of course, I closed Chrome. So we get rid of all of that, and we can type in query. Gives us a little autocomplete here. And now, well, what do we have to play with? So we have circuits. Okay, let's type in circuits. So we know a collection of available circuits. Okay, let's maybe pull the name of a circuit, and maybe we want to know the duration. Now we can run that query, and there's the circuits. If we decide that we want the image URL, well, we know that that's there. And now we can run that, and now we get an image URL. And we can take this and see that it actually is an image URL that actually works if I had internet. Wah, wah. That's the joys of live coding demonstrations. So at any rate, so with this, we can explore and play with the shapes of the data that we want. The really awesome thing about defining these types is it's really easy to add new things, and especially to get away from the cumbersome REST responses. So as we take a look at, what an actual user looks like from the database, there's a lot going on there. If you look at the user model or person model or member model, whatever your current user model is in your Rails applications, it's probably pretty bloated. And so don't judge me too much. But knowing that it's bloated, that's why we want to return. You can customize. You can use custom serializers to get a sparser return. And then if we look at the circuits, so the circuit, that's even more so. So we have the name, the duration in seconds, some difficulty, and then it has this hash of exactly what the workout entails and how to do it. And that's a lot of data coming back if we only need maybe a picture and the workout name. So if we're wanting to implement that here, so say as I want to grab a user with an ID of 1, mainly because I know that's me. I'll take I can have a full name, so I'll do a full name and an email address. I don't have workouts defined yet. And if I try to run that, I'll get an error. And it'll tell me exactly why. So what we can do, I already have a user circuit type. And because I was a chicken, I didn't want to actually live code. I just commented things out. And so we'll go ahead and uncomment this workers field, and I'll walk through what the code is doing here. I'm giving it a custom name because I don't actually have an attribute in the model called workouts. So it's going to be workouts. It's going to be of types user circuit type, and that is defined right here. So this is a GraphQL type, and so the description is going to be completed workouts by user. So this is for the documentation. That's where we get this pretty stuff over here. So the duration, that's all supplied by the description that you supply. And you also know, while I'm here, we have deprecated fields. This is how easy it is to deprecate something. So I used to have an OG image URL, and that is defined in the circuit type. So this OG image URL is the promotional image for the workout. It's using the same property up here, but we don't want to use OG image URL anymore. We only want to use image URL. So we put a deprecation reason in. And now any clients that are using that, or more importantly, any future clients that are exploring the API, can see that OG image URL is deprecated and will likely be removed at some point in the future, so not to use that. And it tells them what alternative to use, to get to be in compliance. So again, living documentation is a wonderful thing. So going back to adding the workouts to the user type, I'm using a Draper decorator here, so this code is really not all that important. Now all that we're doing here is pulling the user circuits, using an includes to get rid of an n+1 constraint or concern. There's a couple of different GraphQL gems. There's one in particular by Shopify that I would highly recommend that does batch requests that also mitigate n+1 concerns. So we'll go ahead and save that. And then I don't think that is using, yeah, and then we'll need to undo the image URL there. And now, refreshing that, we should be able to use workouts. And the workouts, we know that it's a user circuit. So we can come over here and go to user circuit to see what attributes or properties we have available to us. And we have a name, so we'll go name. And we want maybe the image URL. And we'll throw duration in as well. And it'll be that. And so what that does, it takes this view, and instead of rendering the server side, now we can use a Vue component or a Graph or a React component or your JavaScript flavor of the day, and build this component with GraphQL, and if things and only getting back the data that the Vue actually needs to render and nothing else. And I believe that is everything that I wanted to show from a live demo standpoint. So now let's see if we can enter back into the slideshow here. Maybe. And it picks right back up. Nice. Okay. So, live coding complete. I think by now we can all agree that GraphQL is interesting, but we may not know, or maybe interesting is interesting. It's at least intriguing. But before we dive in head first, let's take a step back and spitball some questions. Where do we start? Do we have to rewrite everything? What about production? Do we need a graph database? Because it's in the name. And too long didn't read. The answer to most of those questions is, we'll talk about where we can start. The other questions, the answer is no. And so let's ask a fundamental question. Is GraphQL really all that different than what we're already doing? It's usually presented in a way that's a totally different way of thinking. You have to think in graphs and reimagine your application. And it's using some of these buzzwordy things that I think actually are more harmful to GraphQL than anything else. In practice, GraphQL is just the standardization of things that we're already doing. It's similar to REST. It's another specification. It can be used alongside REST. It could be used as a thin layer on top of REST. So you don't need to rewrite any of your existing REST APIs. You can integrate GraphQL into your Rails application and use it as a thin layer on top of your existing internal APIs or third-party APIs. So GraphQL adoption and integration. So we've already explored, how GraphQL can quickly be integrated into a legacy Rails application. But let's set that implementation, the technical implementation aside for a second, and let's talk about the soft, the people organization hurdles that you'd have to overcome. So where do we start? How do we get buy-in from our teams, from our organization, from our managers? Well, what we're doing at FishMe is we're starting with one component. For us, it's a bigger component, but you start with one component. You implement GraphQL into your Rails application. You use it to talk to your existing REST APIs so that you're not rewriting a whole bunch of code. And you take that one component and you deliver it all the way to production. There's no need for a graph database. The query, you're already running queries. If your queries are already inefficient, you've already got another problem. So GraphQL isn't going to necessarily highlight or create more problems on top of bad queries. And I guess going back to that, with integration, incremental adoption is the key. You think about any technology that's really taken fire and taken hold, be it React, especially true with React, and now more recently Vue. But if you can't incrementally adopt it, just drop it in, create something without a lot of overhead, it's probably not going to take off. So GraphQL can be adopted in the same way in your applications. So GraphQL first workflow. So as you're developing this one component, design your schema first. So the schema is those GraphQL types, that post type, that query type, and use that schema as a contract between your front end and your server. Because now, with that GraphQL schema, you can hand it off to both teams if they're separated, and create different, you can develop the back end and the client view side in parallel. There's great mocking libraries so that the front end can load in a GraphQL schema and get live responses back without the need for an actual working back-end server. And then you can come together and marry those two at the end of the project. Great talk that talks exactly about this and goes into far more depth than I will is Navigating Your Transition to GraphQL by Sashko and Danielle from the Apollo team. Would highly recommend that. So final thoughts. What abilities do you have? So as we're thinking about client and user joy, what abilities do you have to improve client experience and developer experience? You think about those. And then how will you respond with that ability? How will you respond with your responsibility? Response and ability. Embrace your responsibility, be kind, do great things, and continuing building great things. And thank you very much.